Hello, we are Group36. Our research topic is data-centric AI, optimizing bank marketing predictions. In this project, we challenge the common belief that complex models are the answer. Instead, we demonstrate that systematic data governance and preparation, which I have visualized here, are the true drivers of AI performance. I am Lu, and I will start with our data profiling. We used the UCI Bank marketing data set consisting of 45,211 customer records with 16 input features. Our core hypothesis is simple. By rigorously cleaning and preparing this data, a basic logistic regression model can outperform complex approaches that ignore data quality. The first major issue identified is severe class imbalance. As you can see in this chart, 80% of clients said no, while only 12% subscribed. This creates an accuracy paradox. A model could simply guess no for everyone and still get 88% accuracy, but it would have zero business value. Next, we analyzed the categorical features. We found that blue collar and management roles dominate the dataset. Crucially, for the P outcome feature, the vast majority are unknown. This information asymmetry is a key challenge for prediction. Moving to numerical features, we detected significant scoreness. Please look at the balance feature. It has an extreme red score with a value of 8.36. I also use the IQR method to visualize outliers, identifying clients with balances exceeding 80,000 euros. These extreme values can severely distort model training. Finally, I checked for multicollinearity using this heat map. While most features show weak correlations, we did notice a moderate relationship between P days and previous, around 0.45. Okay, with the visual analysis framework have structured for our project now established, I will pass the time to my remaining teammates. They will now guide you through the specific analytical traps and transformation strategies based on these findings.
Professor, this is Wang speaking. Now I'm gonna show you my work. So basically there are two parts. First, I build our baseline model. Second, I try to handle the class imbalance. First, I'm gonna show you my results. Then I'm gonna show you my code. So as you can see, our model is like a highly imbalanced, not our model, our dataset. This is what we care about, the yes part. It only took 11.7%, which are highly acceptable. So here's what we do. First, we build a baseline with nothing, with actually nothing. Then we try to adapt small on it. Then we try to adapt small NC on it. So now we can see the results. As for baseline model, the accuracy is high, but the recall of what we care is like 0.37. So as we change our model, the recall of one keep increase, and the F1 score keep increasing. Though the precision and the accuracy falls a little bit, but I think that's acceptable. Then you may want to focus on the confusion matrix. So as for the first model, the baseline model, so here's the thing. This is the yes class. This is even worse than just a guessing. They classify all most of the points to get a high accuracy. This is better using small, but still not that good. Then we try to use small and see. We got the best results. I think the reason is our model sets contain a lot of categorical features, and using simple small, you may get some meaningless point. For example, you take some random point between 0 and 1, then you got 0.5, which is meaningless. That's bad for our model. Then I'm going to show you our code. So here's a code of our baseline code. Here's it. The whole pipeline is oh, sorry, not here. We try to get the data first, then we encode every categorical feature by using OHE. Then we make sure to split the dataset before standardization to prevent data leakage problem. Then we feed the data into logistic regression, and then validation and visualization. I've already shown the result. So this is a small. We just add a small in it. So this is our final model. Now the whole pipeline is split standardization, small NC, then OHE. As you can see, we we get features for small NC, then we split So with standardization, and after that we do small NC. These are useful because you have to do standardization after split. Then you have to do small NC after standardization, and OHE after that, because we make some change to the categorical features here. So we have to make sure OHE as the final part to encode those categorical features. Okay, my work done. Thank you for listening.
My name is Zhang Zeming, and my work is feature engineering and data exploration. For this program, we mainly care about the record because it can find customers more willing to pay. First, I examined the correlation matrix and found that except PDAs and previous, the correlation among other features were very poor, making it difficult to reduce the dimension. And after baseline, we find a simple copy for resampling has the best effort. So here I only use simple copy for further work. And to prevent data leakage, I follow the pipeline below. First, divide the datasets, then learn the skill and normalization parameters from the dataset, from the training set. Next, perform resampling using simple copy, and finally apply the fitted transformer to the test set and train the model. So first, I turn all two-value features to 1 and 0. And then I only use one hot encoding and standard scalar and get 0.33 recall. After that, I added YG transformation. First, I calculate the skinniness. Despite of PDAs and previous, these two features are more likely two-value feature. Only during and balance are continuous. So I mainly deal these two features. I added YG transform and oversampling. For original one, we got 0.33 recall, and with simple copy one, we got 0.85 recall, which have a huge increase. After that, I added the label encoding for only education, for only months, and for both. Consider the real-world meaning. The unknown may means uneducated, so I set it 0. All those have no influence on recall. Then I consider to remove outliers. For prevent data leakage, I use IQR on training to fit the test. It shows a little reduce on recall, means lost some information when remove outliers. I also have some other tries, like turn PDAs and the previous to two value for only keeping main informations. These have no influence on recall. The other is try scaling on numerical features only. It shows a huge decline on recalls to 0.25. So above all, the basic processing doesn't remove outliers using YG transformation and oversampling.
Hi, hello, Professor. My name is Han Xinyu. So I will first present my presentation and then show the relevant code for the end part. So based on the work of my team member, Wang Zijin, I attempt to conduct some exploratory commercial analysis. So first thing I did was to try using other encoding methods to see if the result on the model would be better. So here, when I looking at our baseline, I realized the standard model was creating nonsensical fake data, while one hot encoding was trashing the natural hierarchy of the education levels. So I rebuilt the pipeline using the ordinal encoding for education and target encoding for jobs. Then switch to small NC to ensure our synthetic data respect the categorical rules. So while the total accuracy dipped slightly to 88%, our recall shot up from the 37% to the 63%. So at the meantime, we are now catching the 26% more high value the customers with the strong 0.89 ROC. So for the conclusion, in short, we choose the data quality over the vanity metrics to build a model that drives real business impact, I think. So for the second part, and I primarily identify some issues with the duration features through the correlation analysis. So for the second part, I check the VAF to ensure the statistic soundness with the H feature peaking at the 5.0 and everything else much lower. We confirm that there are no multicollinearity issues. So I then spotted a major red flag, the duration feature. This is a textbook case of data leakage because you can't know the call length before the call starts. So keeping it would be cheating with the future information. after removing the duration, our RAG org just dropped from the 0.87 to the 0.73. So it's a lower score, but it represents only the performance the model will actually achieve in the real world. So in the conclusion, we choose to treat a fake score for a robust logical model that the business can actually trust. So for the third part here, I choose to focus on the auditing age discrimination. So in our fairness audit initial the results, initial results just stuck at just the 1% for everyone because the model was essentially ignoring all groups. To fix this, I used the EU-Johnson transforms for the smoothness and the smooth for balance, giving the model a basic ability to actually perform. So it works. And I recall the record score just jumped from the 1% to the 64%, and the performance gap between age groups is now only 6%. So effectively, I think this wiped out or just no systemic the bias, I think. So in conclusion, we are proving that quality data perhaps is the non-negotiable foundation for the building fair AI. So the first dimension, I am attempting to explore whether better results can be achieved by enriching the features from the data. So for the first part, we moved beyond the basic cleaning to bridge the gap between raw man numbers and the real business logic. So we use the 1 plus x plus 1 formula to turn the messy PDs into a clear freshness score and put new customer signals via cross-validation. So the impact is our RAG org just jumped from the 0.87 to the 0.89, 2.45% boost. That makes even our simplest models perform significantly better, I think. So for the conclusion, smart data governance is the soul that drives the real-world performance for every model we build. So here is my presentation. And for the last part, I'm going to show you my code section. So starting from here, this is my all code implementations for the 4-dimensional analysis I just introduced. So here is all my presentation. Thank you, Professor.